you read it as goes to. So you have whatever reactants and they go to. And what that means is it goes to produce a product that you're going to write on the right-hand side. And if there's more than one product, you separate them with plus signs. They also will often put the state, whether it's a solid, liquid, a gas, or aqueous, next to the chemical in the chemical equation. And if it's aqueous, that means it's dissolved in a solvent, usually water. So like if you have salt but it's dissolved in water, then you'd put AQ after your NaCl. So here's an example of a chemical equation. We have phosphorus and it's reacting with chlorine and it's creating phosphorus trichloride. You'll notice the phosphorus is a solid. Remember, phosphorus comes in 8s. And the chlorine is a gas. Remember, chlorine comes in 2s. And when it combines in this ratio of 1 to 3. You'll also notice that there are numbers out front because the elements or the compound you're starting out with come with a certain number of each atom. You have to then balance the atoms on both sides because you can't have atoms appearing or disappearing. You have to have the same number. So we have 8 phosphorus in a molecule of phosphorus, and we have 2 chlorine in a molecule of chlorine. And then when we have our phosphorus trichloride, of course, we have 1 phosphorus and 3 chlorines in that. So we have to make that balance out between the reactants and products. So in this case, putting an 8 in front of there balances out our phosphorus on both sides. And then 8 multiplies by your subscripted 3, so we have 24 chlorines in our product here. So we need 24 chlorines. So they come in 2s, so we need 12 of them to make it 24 because the 12 times the 2 also gives us 24. We'll go over more how to balance those, but that's why those numbers are there, and they're called coefficients. So those coefficients are placed in front of a reactant or product on those sides, and that ensures that you have the same number of elements on both sides of your reactant, and that's called balancing a chemical reaction. And they need to be balanced because of the law of conservation of mass, which means that in a chemical reaction, not necessarily a nuclear reaction, but a chemical reaction where there's bonds being broken or created, you have mass that is conserved. It is neither destroyed nor created, so it's got to be the same on both sides. So for balancing a chemical equation, you'll first check to see the number of atoms on each side is the same. For those that are different, you'll put coefficients in front of the chemicals they're in to balance the number of atoms on each side. So you'll use the smallest possible number you can use to do that. And then you'll go back and recheck your balancing. Make any adjustments that are necessary. If you've balanced something and thrown off another element, then you've got to go back and rebalance that element that may have been balanced to begin with. So I've given you some equations here. Go ahead and practice. See if you can insert coefficients to make them so that they balance. Your first one here, for example, we have 2 oxygen and 1 carbon, and in our product we have 1 carbon and 2 oxygen. So that one is balanced, and we don't have to do anything. The second one here, you have 2 hydrogen and 2 oxygen, and in our water we have 2 hydrogen and 1 oxygen, so that isn't balanced. And so we would have to put, to balance our oxygen, since we have 2 on the reactant side and only 1 on the product side, we would have to put a 2 out front as a coefficient in front of our water. And then that throws off our hydrogen because that 2 will multiply by the subscripted 2 and give us 4. And we only have 2 on the reactant side, so then we have to put a 2 in front of our H2 to make that balance. And in that case, you won't have to put anything in front of your oxygen. You just leave it blank because if you leave it blank, it's assumed to be 1. So you've got 2 other reactions here. See if you can balance those as well. And there are lots of other examples in your text that you can look at and see if you can balance. So just a summary of what we've gone over for chemical equations. When you write them, you write the reactants on the left with an arrow and then the products on the right. You separate them with plus signs. And then the coefficients are whole numbers that you place in front of the substances you have so that they balance throughout the entire equation. And then the states of the elements are written after the substance. An S is a solid, an L is a liquid, a G is a gas, or AQ is aqueous, which means it's in water, and you just put them in parentheses. So to balance those equations, you first write basically what your reactants and your products are, and then you're going to count the number of elements on both sides of the equation to see which elements are unbalanced. Balance the elements one at a time. Usually leaving hydrogen second to last and oxygen last makes it easiest to balance them, although occasionally it is okay to balance oxygen or hydrogen first. And the reason is hydrogen and oxygen tend to be in more substances than the rest of the elements. So if you get the other ones all balanced, then you just have to do slight tweaking to balance your oxygen or hydrogen, and often they are already balanced because you've balanced the other elements that are there, so it's just easier that way. After balancing each individual element, check all the other elements that you've influenced by that coefficient you inserted to make sure that they're still balanced. And if they're not, then go through and then do a final check when you're all done. Write down each element on the reactant side and the quantity that you have on the reactant side, and then write each element on the product side and the quantity there to make sure the elements are balanced and that the coefficients are the smallest number of whole numbered coefficients possible. So for example, when you get done, if all of your coefficients are even, then you can divide them all by 2 and make them smaller numbers. That's kind of how you check. Is there a number you could divide every single coefficient by? And if you can, do so, because you'll get a lower number in front of each one and they'll still be balanced.